Hello, I'm Eugene Kim. I'm so glad to talk about our work, Modularized Transfer Learning with Multiple Knowledge Graph for Zero-shot Commonsense Reasoning. Let's start with a simple example. Common sense reasoning is a whole process using background knowledge, which is not written in the context. As you know, common sense reasoning is a key factor in daily communication, so already lots of works have been carried out. Also, there are various benchmarks that requires different type of knowledge, such as the common sense QA for informative common sense and social QA for emotional and social common sense. Based on those benchmarks, the state-of-the-art models already achieve the human level accuracy. However, recent studies are adopt, do language models will really learn general reasoning? For example, the model trained on task A dataset shows human level accuracy in task A. However, its performance declined dramatically on the other common sense reasoning tasks. These results can be interpreted as large-scale neural system does not really learn how to perform general semantic reasoning, but just learns simple individual data set. In this vein, zero-shot evaluation is suggested as a genuine measure for generalizability. In zero-shot setting, to learn QA system without any training data set, recent works use synthetic QA data set, which is generated from a single common sense knowledge graph, and they use it for training the model. This kind of QA system works really well if they learn with the common sense knowledge graph, which has the equal type of knowledge with the task, what the task needed. However, it is really hard to know which kind of common sense knowledge graph has a strong alignment with the arbitrary task. Also, considering the real world task usually requires various type of common sense at the same time, it is hard to apply it in the real world. Of course, the physical integration of the knowledge graph can be a naive approach. However, there is a loss of the knowledge inevitably because of the heterogeneity of the knowledge graphs. Therefore, we believe that neural CSK integration is needed. Also, as new CSK will continue to appear, we think the scalability in framework is really important. Based on those ideas, we thought zero-shot QA system for real world should utilize multiple knowledge graphs, considering neural CSK integration and scalability. Based on those ideas, we proposed the modularized zero-shot framework. I will present overall structure first and then explain specifically. First, we generate synthetic QA data set for each knowledge graph. Then train the expert adapter for each knowledge graph using synthetic QA data set. Then using those pre-trained expert adapter, we train the zero-shot fusion layer using the balanced mixture data set, which is of the synthetic QA data set. Further, to overcome the limitation because of the zero-shot setting, we suggest the KGC adapter. We train it with the KG classification data set and apply it into the zero-shot fusion. So let's start with the generating synthetic QA data set. We repurposed the method from the Kaising Ma's paper. So we extract a triplet from a common sense knowledge graph and randomly sample the other triplets which has the same relation with it. Then we convert the head entity and relation into the question using the template. And then we use tail entity of the triplet as an answer and the tail entity of the other triplets into the distractors. To utilize the synthetic QA data set without any loss of its intrinsic knowledge, we use adapter module, which is used for the expert adapter in recent works. In this paper, we use adapter module as a KG specific parameter. So we add the adapter layer into the transformer block. So during the training, we only train the parameters of the adapter. Therefore, we can parallelize the training of the adapter for all cages. And then once the expert adapters are trained, we use adapter fusion to aggregate the knowledge of each expert adapters. Adapter fusion is one of the multitask learning approach that alleviates the interference and the catastrophic forgetting. Originally, it is based on the learning algorithm that using the training data set of the target task for training the fusion layer. In this case, considering zero-shot setting, we use the balanced mixture data set instead of target task training data set for fusion training. As like adapter training, we add the fusion layer into the transformer block and transformer block. And actually the adapter fusion is attention line mechanism. So we use the representation of the pre-trained language model as a query and the representation of the expert adapters as a key and a value. However, still there is certain limitation because of the discordance between the target task and the train task. So we believe that the representation for the query should be more knowledge awareable. So we convert the synthetic QA data set into the KG classification data set with a simple transformation. So this is how we made the KG classification task. So we just concatenate the question and the answer for the question to the KG classification task and the source of the knowledge graph as an answer. So after training with the data set, we add the KG classifier adapter into the fusion layer, and we use the representation of it as a query. So from now, I will explain about our experiments. We used 4 kinds of common sense knowledge graph, and we conduct zero-shot evaluation for 5 common sense reasoning benchmarks. These are the baselines we suggested, including the recent works for the zero-shot QA system. And here the number 4, MTL, denotes the model which is trained in the conventional multitask learning method using the whole synthetic QA data sets. So as a result, our zero-shot fusion achieves the best performance in all benchmarks except Vino Grande, and it shows highest average score. And also it shows consistent improvement over multitask learning, and especially the zero-shot fusion with KG classifier adapter shows the improvement in average score. These results implies that our framework helps to perform general common sense reasoning, and the KGC classifier helps our framework to generalize better. So we did analysis for the impact of the KG classifier adapter. First, to figure out whether KGC adapter aware KG alignment for a given sample, we compared the TSNE visualization of the pre-trained language model and the KG classifier adapter. As you can see, the representation of the KG classifier adapter classified the unseen sample of different benchmark more well. So we can say that KGC adapter generates a relevant KG aware query, and it will help to fuse representations from suitable expert adapters in our framework. And we analyzed about the effect of KGC adapter in our framework. For that, we compared the attention probability of the zero-shot fusion with and without KGC adapter. As you can see, we observed that KGC adapter fuses the knowledge from different experts with a subtle difference rather than focusing on a single expert severely. We believe that this kind of results enables the delicate balancing between multiple knowledge sources. And then we also analysis about the interference of our work. So before that, we defined the STL model as the model which is trained with a single synthetic QA data set. And using it, we suggest the interference ratio. It is the ratio of the number of incorrect prediction of multi-cage model over the number of correct prediction of STL models in common. Simply, we can say that interference ratio count the ratio of the case that knowledge aggregation make correct prediction wrong because of the interference. As you can see in this graph, the zero-shot fusion mitigates interference between different types of knowledge compared to multitask learning. And for the last, we explore the knowledge aggregation according to the number of the knowledge graph. So this is the y-axis in this heat map shows the combination of the knowledge graph that we used. And the red color shows the decrease of the performance, and the green color shows the improvement of the performance. So as the number of the knowledge graph increases, while the multitask learning shows decrease in the performance, our framework shows the improvement in the performance. So we can say that zero-shot fusion enables knowledge aggregation for multiple knowledge graphs synergetically. So I will wrap up this presentation with our contribution. We suggest a transfer learning using multiple knowledge graphs with the synthetic Q data set in 3 different ways. As a result, we mitigate the interference for knowledge aggregation from multiple cages and achieve significant improvement in zero-shot commonsense reasoning across the tasks. Thank you for listening to my presentation. And if you have a question.
You have time to ask some questions. If not, I can start with a couple. Can you explain the synthetic question generation part? I think you went past one.
Oh. Oh, this is the same method from the Kai-Sigma's paper. So we select a certain triplet randomly, and then we select the other triplets that has the same relation with it. Then the triplet that we select for the question, we change the head entity and relation into the question on the right side. The losing weight is 4, like using the template. And then the tail entity of it using as an answer, and the other triplet that we randomly sampled, use it for the distractors of the multiple choice question.
I'll ask another question. So if you go to the first results where you have the Pika data set, I'm not very familiar with that data set, the PIQA data set.
Oh.
Just trying to know, I think the results. Here.
Yeah.
So the results on the PIQA data set, are they statistically significantly better than the Roberta large?
Oh, sorry,
are they better than the Roberta large system? The results on the PIQA data set?
Ours is higher than the Roberta large.
Yeah, are they? I was trying to know, are they significantly better? Like, how big is that data set?
Oh, I'm a little confused about the size of the data set, but it's the benchmark that we use has similar size of benchmark as the size. So is that it can be answered?
If there are no other questions, let's thank the speaker again.
Thank you.
The final talk of today's